Hi, Keith here. In this video I want to look a little bit more at correlations and in particular at what the value of the correlation coefficient means. Now what I'm saying applies to both the parametric or Pearson's correlation coefficient and to the non-parametric or Spearman's correlation coefficient. Now the difference between these two is Pearson's, or the parametric, is used when both variables are quantitative. That is, they're both measurements or counts or speeds or something of that nature. You've got a quantitative variable on the x-axis and on the y-axis. And the four graphs here, which I'll get to in a minute, clearly are for quantitative variables on both axes because there's a lot of different values being taken on. So if we go across the x-axis, there's a lot of values and a lot of different values on the y-axis. The non-parametric or Spearman's correlation coefficient is for when situations where one or both variables are ordinal, that is, they're ranked variables. And if one of these variables or both variables were ranked, then we would see some points sitting on top of each other because they had the same value for the x or for the y. The first tutorial problem, for tutorial 7, has two ranked variables. One variable is the amount of time spent studying, and there are set categories, and the other variable is grade, and grades are a ranked or ordinal variable because we can put them in order. Now, both correlation coefficients range from 1 to -1, and in both a positive value indicates a relationship that's sloping up, such as we have here, and a negative value indicates a relationship that's sloping down, as we have there. The closer the value is to -1 or +1, the better the relationship is. In other words, the closer the points are to a line running through them. Now, this little website here, or this little app, allows us to test our understanding. So the link is up there, you can see it. This allows us to test our understanding of correlations. So what I've got to go through is all four graphs and match up from down here what the correlation actually is. Now, because we've got four graphs and four numbers, it's not that tricky. This one down here is the only one that's sloping up, so it's got to be that one there. Then if we look at the remaining three, they're all sloping down, they're all negative, but they vary in how strong the correlation is. Here it's fairly weak, so I'm going there. Here it's a bit stronger, so I'm going there, and here it's quite strong, so I'm going there. And I get 4 smiley faces, so I've got all of those correct. And I'm not going to bother doing this a lot, but I'll do just one or two more to illustrate. So here, very strong positive, it's got to be that. Fairly strong positive, got to be that. Negative, there's only one negative in there, that. And weak positive, got to be that. Last one, they're all negative, they're all going down, so that's the sloppiest, so I'm going there. That's the next sloppiest, I'm going there. Now these two are going to be tricky, so I'm going there and there, because this one is a bit tighter than that one there. There we go. Okay. What I'm just tried to do there is give you an understanding of what the correlation coefficient means. Now, the correlation coefficient is better in some ways than a t statistic or an f statistic or a chi-squared value, because the correlation coefficient is directly interpretable. I simply compare it to -1, +1 and 0, and the closer it is to -1 or +1, the stronger the relationship. And then positive or negative just tells me which direction. let's press again. A positive, both variables are increasing together. A negative, one variable, the y variable, decreases as the x variable increases. And being directly interpretable is a very nice value or very nice characteristic for a test statistic to have. What I've said applies to both the parametric and the non-parametric, but with the non-parametric or Spearman's, we're not looking for a linear relationship. The parametric looks for a linear relationship. The non-parametric looks for a steadily increasing or steadily decreasing. So instead of a line, it could be a curve going like that, or like that, or like that. Okay, hopefully that is of some help.